Let's look at another example where we're wanting to find the equation that matches up to a particular line. Let's suppose we are told that we have a line that passes through the points -4, 2 and 6, 6. If we were to plot those 2 points on the Cartesian coordinate plane, there's a straight line that we could draw between those 2 points. That's all that's required to define a straight line is 2 points. So there's a straight line that contains those 2 points. And we want to know what would be the equation that matches up to that line. What would be the equation that would have those 2 points as solutions? So we're looking to find the equation of the line that passes through those 2 points. And we're again going to concentrate our efforts on the slope-intercept form of the equation. Remember the slope-intercept form. When the equation is solved for y, with y having a coefficient of +1, the coefficient of x, or what's called m, is the slope of your line, and the constant, or what is called b, is the y-intercept value of your line. So we're going to concentrate on working with the slope-intercept form to find the equation of the line that would contain those 2 points. Well, again, if you have 2 points, one thing you can immediately calculate for the line would be the slope of the line. If you have 2 points that are on the line, you can always calculate the slope of the line. Remember, slope is change of y divided by change of x. So what's our m value here? What's our slope value? Well, the y went from 2 up to 6. That's an increase of 4. The x went from being over at -4 over to +6. That's an increase of 10. 4/10, that reduces to 2/5. Unless it's an application problem, you will typically see mathematicians leave the slope as a fraction. In an application problem, they will oftentimes convert slope then to a decimal. But just in a strictly algebraic instance, a non-application instance, they would leave the slope as a fraction. So now I know that my m value, my slope for my line, is 2/5. And I just need to fill in a value for b. But remember what we did before. Whatever this b is, it has to make these points solutions. So let's take one of those solutions, plug it in place of x and y, and that will create an equation that we can solve for b. So let's take the point 6, 6. I'm going to put 6 in for y. I'm going to put in 6 for x. And now, look, I've created a linear equation in one variable that has just the variable b, and now I can solve that, and I'll know what my b value is. I'll know what my y-intercept value is for my line, and that will give me my equation. So we have 6 equals 12/5 plus b. Ooh, fractions, we're not real thrilled. Well, then why don't we get rid of the fractions like we did before in solving linear equations with one variable? Let's multiply both sides of the equation by 5. So I have 30 equals 12 plus 5b when I distribute that multiplication of 5 times both of those terms. Or 18 equals 5b, or b equals 18/5. And now I have my b value. So my equation is y equals 2/5 x plus 18/5. And here is the equation that would contain those 2 points as solutions. Let's check them and see. If we let x be -4, what's 2/5 times -4? Well, that's -4 over 1. That's -8/5, isn't it? And -8/5 plus 18/5 is 10/5, which is 2. If x is 6, that's 12/5. 12/5 plus 18/5 is 30/5, which is 6. So indeed, this is the equation that contains those two solutions. This would be the equation that would be related to the line that you could draw with those 2 points. And we've gone, again, from points on the line to the corresponding equation. Just the exact opposite of what we originally did with linear equations in 2 variables. Originally, we took a linear equation in two variables, found points, and from the points drew the line. And now we've seen that we can come full circle and get the equation when we know points on the line.